All right, guys, this is going to be for homework 17. This is going to cover the concept of X and Y intercepts. You already know what a Y-intercept is. We're just going to talk about X-intercepts, how you can use both of those to graph, okay? So before we get going, this isn't a very long lecture at all. This will maybe be the shortest lecture of the year because this is just one more way to graph. You already know 2 different ways to graph. And in fact, I want to take a minute because this is kind of a short lecture. I want to take a minute and review just quickly about graphing. Just in general, what have we said about graphing? We know 3 ways to graph, or 2 ways to graph. We're going to be talking about the third one today. First way to graph is y equals mx plus b, excuse me. Second way to graph would be, the name is the table method, but y'all would probably just say, you know, picking points. Where you pick some x, you plug it in and just see what the y is. And the third way, and there are other ways to graph, but these are the 3 we're going to talk about, is using x and y intercepts. All right, so we'll get to that in a minute. Let's just quickly review these 2. Yeah, I guess I can go and use a piece of graph paper for this, make it clearer. All right. So just quickly, how to do you know, the other 2 ways to graph. You should know this. I mean, you just took a test on it, so hopefully you're aware of this. But just to remind you. All right. Let's just say I wanted you to graph y equals negative 3/4 x plus 5. Okay, y'all have accused me of using the same numbers over again. I don't know, just something in my brain, I guess. So I probably graphed this exact one before, knowing the way I do things. So bear with me here, but we have a y-intercept of 5, which is, you know, again, sort of the focus today. That's the b, which is, remember, the y-intercept. So that's going to be 1, 2, 3, 4, 5, positive 5 right there on the y. And then our slope is negative 3/4, or 3/-4. Remember, where you put the negative doesn't matter. Put it on one of them. I'm going to put it on the 3. So that's going to tell us to go down 3. And then because the 4 would be positive if I put the negative on the 3, we're going to go right 1, 2, 3, 4. And the other point would be there. Remember, you can do this multiple times. You can say, all right, so down 3, right 4, down 3, right 4, 1, 2, 3, 1, 2, 3, 4. Put another one there. If you did go the other way, if you did put the negative on the 4, the 3 would be positive and you would have gone up 3. And then the 4 would be negative and it would have been left 1, 2, 3, 4. And as you can see, these are all falling on the same line here. And then we have our graph. All right. So y equals mx plus b, definitely the most efficient way to graph. What are the weaknesses to it? And that's really what we haven't talked about too much. Well, the weakness to pretty much any of these methods is fractions or decimals. If you, let's say your y-intercept was 2.9, I mean, it's on the graph, right? Because here's 2, here's 3, 2.9 is somewhere in there, but where exactly? You don't want to ballpark this kind of stuff. So it's one of those things where if you get a fraction for your y-intercept, you're going to have to try graphing another way. I don't think it's in this homework, but I believe down the road you will get a homework where it'll be in y equals mx plus b, but the y-intercept will be a fraction and you won't be able to graph it because it's not, you know, it's not clean. So fractions are sort of the weakness here. If the y-intercept is not a clean number, it makes it a real pain in the butt. So that's y equals mx plus b. What if you know, let's say you got something kind of like this on the test. This is one of those things that people mess up, and a lot of y'all did kind of goof this up on the test. You said, well, that's a horizontal line. No, it's not. Remember, horizontal lines don't have both variables. But let's just say you're on the test and you kind of just froze. You're like, you know, that's almost so simple looking, I don't know what to do with it. Remember, you can make a table and just pick some x's and plug them in and see what y's you get. I'm going to have to kind of squeeze the math in on the sides and around it here. But so let's just start with 0. Plug in 0 for x and let's see what we get for y. So if I put in 0 for x, I'm just going to make it small here, right? If I put in 0 for x, 0 times negative 4 is 0. And so y equals 0, right? When I stuck 0 in for x, I got 0 for y. There's one of my points. Let's pick another point for x. Remember, these lines go on forever. You can pick anything you want. Let's pick 1. So over here, we'll do it here. Y equals negative 4 times 1, right? So that was my x. I put in 1 for x. So negative 4 times 1 is negative 4. So y equals negative 4. I put in 1. I got negative 4 for y. There's another point. And let's just go ahead and do negative 1 just to change it up a little bit. We'll do that one down here. So if we had y equals negative 4, and this time we're putting in negative 1 for x, right? So y equals negative 4 times negative 1 is positive 4. And so that one is 4. Now you have 3 points. 0, 0, which is in the middle, 1, negative 4, 1 on the x, negative 4 on the y, negative 1 comma, or excuse me, well, you could write this as a point, right? Negative 1 comma 4, negative 1, 4, so that's negative 1 on the x, and then 1, 2, 3, 4 on the y. Kind of a steep line here, right? But that's it right there. So remember, if you kind of get something you're not familiar with, you can just plug x's in and see what you get. What's the weakness with this method? Well, you have to do a bunch of solving. And there's no guarantees that the numbers you pick are going to come out clean. I mean, in this case, they will because I picked a fairly simple equation. But you might put in 2 and you might get out 7/19 as the y. And you just can't use that point, right? Graphing with fractions is basically, unless the graph you're using goes up by halves or something or thirds, you can't use those. So the weaknesses for both these, the weaknesses for all the methods is fractions. If you are, trying to graph y equals mx plus b and the y-intercept is a fraction, you're gonna have trouble. If you're on the table method and you plug in a number and get a fraction as an answer, you're just gonna have to try something else. So keep that in mind, okay? So those are the 2 ways we've talked about graphing so far. Just like I said a minute ago here. Where is it? There it is. Just like I said a minute ago here. That was y equals mx plus b, and the table method, because we made a table, also known as picking points. So the new concept today is x and y intercepts. Now you already know what a y-intercept is. We'll come back to here for a minute and we'll go back to the graphs. You already know what a y-intercept is, right? The y-intercept, let's just draw a little generic graph here, just something, whatever. The y-intercept would be right here, right? It's where it crosses the y-axis. Well, it also has an x-intercept, doesn't it? Because it crosses, let me mark the axis for you too. It crosses the x-axis somewhere as well, doesn't it? We haven't talked much about this because the x-axis isn't really part of y equals mx plus b. X-axis, what am I saying? X-intercept, sorry, on the x-axis. We haven't talked much about it because it doesn't have anything to do with y equals mx plus b, right? This is the slope. This is the y-intercept. The x-intercept has nothing to do with this, so we just didn't talk about it. But there is a y-intercept and there is an x-intercept in every graph, right? If I draw one over here and it goes like this, it still has an x-intercept right there, and it still has a y-intercept right here. Every line will have x and y-intercepts, both of them, except what? A vertical line or horizontal line, right? Even if the line was going the other way, it still has an x-intercept and it still has a y-intercept, right? So every line, unless it's vertical or horizontal, but you should already know how to recognize those, will have x and y-intercepts. So what we're going to do, if I find the x-intercept, that would be, we're running out of room here, that'll be 1 point. If I find the y-intercept, that'll be a 2nd point. And how many points do you need to make a line? 2. When I'm doing the table method, I like to do 3 just to be sure, but you really only need 2. So the idea here is find the x-intercept, find the y-intercept, and graph your line, okay? The only other thing we need to talk about, and this is very important, I'm gonna say this a couple times, but oops, excuse me, but make sure you get this down. You can tell part of the value on these points already. Like, let's just do another one here, like right here. We'll draw a nice graph or a semi-nice graph, something like that. And let's talk about the y-intercept right there. What can you tell me about the point? Think about this point right here, the y-intercept. What can you tell me about it? Well, not much other than it's positive, right? It's up here, so it's positive. But how far up is it? Well, you don't know because I didn't mark the graph, right? That might be up 1. That might be up 5. That might be up 100. We just don't know. But you do know that it is on the x, or that it's on the y-axis, right? So think about it. If I come over to this point and I want to fill in one of these values, I don't know what the y value is. Again, it might have gone up 2, it might have gone up 1,000, it might have gone up 9.5. We just don't know because I didn't mark it. But what's the x value for that point right there? Isn't it 0? Think about it. This point right here, what's the y value? I don't know. What's the x value? 0. What's the x value right here? 0. What's the x value right here? 0. What's the x value right here? 0. No matter where you are on this line, the y will change. It'll be positive, it'll be negative, but the x value of the point will be 0, yeah? So y-intercepts always have 0 for the x. So half that point is filled in already. X-intercepts, like just, whatever that guy right there, the x-intercept. Same kind of thing, except it's backwards. Here, I don't know what the x value is, right? I have no idea what the x value is. I might have gone over 3, I might have gone over 7, I might have gone over 14.3, who knows? But what's the y value of this point right here? Think about what I said about the y-intercept. It's a little bit backwards this time. Right here, what's the y value in the center? 0. If I go to the left, has the y value changed? No. If I go to the right, has the y value changed? No. So wouldn't you agree? If you're here, 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 anywhere on this line, the y value will be 0. So that's really the point here, y'all, and this is important. The x-intercept has a y value of 0, and the y-intercept has an x value of 0. Sorry for the giant monkey hand in the way there. Make sure you get that down. That's the key to doing these problems, okay? So take a minute, digest, go back over anything you need to go over, and then we'll do a couple examples graphing like this, and that's going to wrap us up. All right, so one more time. Again, I mean, whether the explanation made sense or not doesn't really matter. I mean, hopefully it did. This is the point. The x-intercept always has 0 for the y value, and the y-intercept always has 0 for the x value, okay? So let's graph a couple problems here, try this out. And I think you'll get this. I don't think it'll be too big an issue for you. All right, so let's try our hands at a couple examples here, and that'll pretty much wrap it up. So let's say I asked you to graph x plus 3y equals, I don't know, -6. Remember, if the test doesn't specify, you can get this into y equals mx plus b if you want and do it that way. But let's say they asked you, what's the x-intercept? What's the y-intercept? Well, then you're going to have to do it this way, okay? And there are questions on the test that'll say graph using the x and y-intercept, so make sure that you are able to do this. So remember, this is the key point that we were just saying. We've got to remember that we already know one of the values here. The x-intercept has 0 for y, and the y-intercept has 0 for x. That's immediate, okay? So the x-intercept, we know that the y is 0. For the y-intercept, we know that the x is 0. And all we're going to do is plug them in and find out what we get. So let's do the x-intercept first here. We know that, again, the y is 0. So I'm going to plug in 0 for y. So we have x plus 3 times 0 for the y equals -6, because, again, x-intercept 0 for y. 3 times 0 is 0. That's gone. X equals -6. So the missing value here was -6. Okay, make sure you're cool with what I just did. Plugged in 0 for y and found the missing value of -6 for the x-intercept. For the y-intercept, we know that the x is 0, so similar but different. We'll put in 0 for x plus 3y equals -6. So that's 0. So that's just 3y equals -6. Divide by 3, and y equals -2. So the missing value when we plugged in 0 for x, y was -2. And now you have the 2 points, and now you can graph. -6 on the x-intercept, 1, 2, 3, 4, 5, 6. -2 on the y-intercept, so that's down 1, 2. And that's your line right there. Again, if I could draw a straight line, it would be nice, but y'all get the idea. Kind of doing this from a weird angle. Sorry about that. So make sure you're clear on that. One example, we'll do another one here, but that's really all you're doing. Just one of these after the other. Again, pause, redo it yourself, anything you need. You don't have to go at the speed that we're moving here. So let's say, and again, they don't all look the same. I mean, again, it's probably not going to be in y equals mx plus b, because if it was, that's just how we graph it. Let's say I gave you 4x equals, I don't know, I want this to come out, -5y plus 20. Something like that. And again, I want to know what the x-intercept is. I want to know what the y-intercept is. And then I want you to graph with them. So fill in the part that you already know. You know the x-intercept has 0 for y. You know that the y-intercept has 0 for x. And those parts are done. So let's go ahead and find the x-intercept, where we know that the y is 0. So we'll have 4x equals -5 times 0 plus 20. We'll have to do a little solving. That's why we went through the solving unit, right? So -5 times 0 is 0. So we'll have 4x equals 20. Divide by 4, and x equals 5. So when we plugged in 0 for y, we found that the x was 5. Now we have one of our points. Now over here, we'll do the y-intercept. Remember, we know x is 0. So we'll have 4 times 0 equals -y, 5y, excuse me, plus 20. 4 times 0 is just 0. So 0 equals -5y plus 20. How you do this is up to you. move the 5y, move the 20. I'll probably just add 5y to both sides. So now I have 5y equals 20. And again, how do you get the 5 off the y? You just divide by 5. And y equals 4. So a little more work on that one probably. When x was 0, y was 4. So the x-intercept is 5. 1, 2, 3, 4, 5. The y-intercept we just found was 4. 1, 2, 3, 4. And there's your line. Let me see if I can make this one a little bit nicer. That's a lot better. Or at least a little bit better. All right, so you guys get the idea. You graph the y-intercept, you graph the x-intercept, and you're done. Let's do one more. Like I said, this is not a super long lecture, but I do want to do just at least 3 examples. There will be some review questions in the homework. You're going to start seeing that show up more and more often. They'll probably have you go back and do a little solving. They might go back and have you graph with y equals mx plus b, just to, again, just to review. All right, let's say we said one more, x equals -6 minus 2y, something like that. All right, same deal. I want to know the x-intercept. Hopefully you can fill this in by memory by now, which has 0 for the y. I want the y-intercept, which has 0 for the x. And we just got to find those 2 values and we're good to go. So the x-intercept, we know that the y is 0, so plug 0 in for y. We have x, I don't know what that was. X equals -6 minus 2 times 0. Yeah, let's ignore that. We go in here, x-intercept, 0 for y. So x equals -2 times 0 is just 0. So x equals -6. That one was nice and easy. Now the y-intercept, we know that the x is 0. So I'm going to put in 0 for x. And then how you solve this is up to you. You can move the 6 or the 2y. It doesn't matter. I'm going to go ahead and just move the 6 because it's in the front. So we have 6 equals -2y. Don't drop the negative off. And then how do you solve for the y? You divide by -2. So -3 equals y. And that's the missing value for our y-intercept. So again, once you find the values, you're pretty much done. Y-intercept is -3, 1, 2, 3. X-intercept is -6, -1, 2, 3, 4, 5, 6. And there is your line. So hopefully that's making some sense, guys. I would encourage you to get into this method because it's actually pretty easy as long as you don't get fractions. But that's true for all of the methods. Wow, that actually looks really terrible. Sorry about the bad lines, guys. You know the drill, though. It's just one of my quirks, I guess, as a teacher. Anyway, let me know if you need any help. As usual, review the graphing stuff because that's pretty much all we're doing going forward. Make sure you're comfortable with the 3 methods of graphing: y equals mx plus b, table method, and now graphing with the x and the y-intercepts. And I'll see you guys in the next one.